How to do a dihybrid cross. Well, a dihybrid cross is when you're trying to look at two different traits at the same time. So in a dihybrid cross, you're going to have two different keys, one for each trait. So let's start by making this trait. All right, so for problems 1 and 2, use the following information. In fruit fly, gray bodies are dominant over black bodies. So let's make that key. Big G, gray. Big G, gray. Little g, black. And normal wings are dominant over small wings. Big N, normal. Big N, normal. And little n, small. So those are our two keys. Now it's time to do a dihybrid cross. So cross two flies that are both heterozygous for body color and wing size. All right, so what's our cross? They're both heterozygous. So big G, big N, little n, crossed with big G, big N, little n. Now, something you should realize is that this is one of the parents, right? Why do they have two G's? Well, they got one from their mom and they got one from their dad. Why do they have two N's? Well, they got one from their mom and they got one from their dad. So that means that for a fruit fly, they need two G's and two N's, which means inside these boxes, you should end up with two G's and two N's, just like the parents. So let's say this is the dad. When he makes sperm, he needs to put one of the G's and one of the N's in every sperm. If this is the mom, she needs to put one of the two G's and one of the two N's in every egg. So let's think of all of the possibilities. So if you have a big G with a big N, big G with a little n, little g, big N, little g, little n. Those are the four possible combinations. Let's do it again for the mom. Big G, big N. Big G, little n. Little g, big N. Little g, little n. So now that we know what all the sperm would be like and all the eggs would be like, we can fill them in. Big G, big N. Big G, little n. Little g, big N. Little g, little n. Same thing over here. Little g, big N. Little g, little n, little hole. All right. So there's our Punnett square. Now when we fill it in, if this sperm fertilizes this egg, and when I write it, I'm writing the two G's and the two N's together because it just is easier to figure out the phenotypic ratio and what they actually look like if you do it that way. So big G, big N, little n, big G, big N, big G, big N, little n. All right, so now the phenotypic ratio, how do you go about doing that? Well, you have to figure out all your possible genotypes and count how many, phenotypes and count how many of each. So what are all the possible phenotypes? Well, you could have a gray body, normal wings, or a gray body, small wings. or black body, normal wings, or black body, small wings. So those are the 4 possible phenotypes. So now what we just got to do is count up how many of each of them. So this is gray normal, gray normal, gray normal, gray normal, gray normal, gray small, gray normal, gray small, gray normal, gray normal, black normal, black normal, gray normal, gray small, black normal, and black small. So there are 9 that are dominant. There are 3 that are dominant recessive. There are 3 that are recessive dominant. And there is 1 that's recessive. Sorry, this could be neater. So it's 9, 3, 3, 1. Okay, so the 9, 3, 3, 1 ratio. And that is how you do a dihybrid square. Now, I'll do one more quick problem with you on the back side here. So in this one, really quickly, some dogs bark while chasing game, others are silent. Some perk up their ears, some do not. Barking is dominant. So big B is bark. Big B, little b is bark. Little b is silent. Okay, and erect ears are dominant over droopy ears. So big E is erect. Big E is erect. And little e is droopy. So why am I doing a second example of dihybrid crosses? So I can show you the shortcuts. So let's take a look at this one. What kind of puppies would you expect from heterozygous erect-eared? So heterozygous erect-eared, heterozygous barker. So big B, little e, little e. And a droopy-eared silent trailer. So droopy-eared silent trailer. So little b, little e, little e. All right, so for the first parent, big B, big E, big B, little e, little b, big E, little b, little e. For the second parent, little b, little e, little b, little e, little b, little e, little b, little e. So now let's put these here. Big B, big E, big B, little e, little b, big E, little b, little e. Now for this one, you might be wondering why I don't have 4 rows here like on the back side. It's because they would all have little b, little e. So they'd all be identical. So all 4 of these rows would be identical because all of these sperm or eggs, depending on if it's the male or the female, all these gametes are identical. So you don't have to do all 16 boxes, just do the one since they are identical. And then you would fill this out. So big B, little b, big E, little e, big B, little b, little e, little e, little, big, little, and oops, sorry, my bad. That's supposed to be an E. Some of you back are going, what? All right, there we go. So those are the 4 possible puppies. If we'd done the whole thing, then they'd all say the exact same thing. So it doesn't matter. So you've got barking. What are the 4 possible phenotypes? Bark, erect, silent, erect. And then bark, droopy, silent, droopy. So how many of each? So there's bark erect, bark droopy, silent erect, silent droopy. So it's 25% of each. So yeah, 1 out of 4, 25% of each. And if we'd had 16, it would still be 25% of each. All right, that's long enough for this video.